Okay, so let me get started with today's class in that case. Okay, so let's see what is in store when you're going to talk about the 5G core networks. So there is a lot of evolution or kind of transformation as you go from 4G to 5G. So before I talk about 5G, let's see what used to be the case with the 4G. In 4G, if you recall in the previous class as well, I was talking about the architecture of the 4G system where I was talking about different elements like eNode B, MME, S gateway, P gateway, PCRF, and etc. So we call all of them as like a different functional entities. Basically, you can treat each of them more like a network function offering certain kind of services depending on the requirement. One example could be tracking the user mobility and paging the users, especially when you're getting incoming call or incoming messages. All that kind of thing can be realized using different modules and different functions in the network. And another important point with the 4G networks is we are talking there only a single core network, which is deployed on dedicated hardware. Many times what happens is this dedicated hardware, which kind of realizes these 4G networks are kind of proprietary in nature. Even though here I'm talking about 3GPP specifications, the specifications only talk things only to a certain extent. The low level details are not really talked about in the specification. For example, you can think specifications more like algorithms, and what a different manufacturer do is they taking these algorithms and implementing in different ways. So you can think loosely that is a kind of analogy here. So there we are talking about things that are kind of tied with one manufacturer, and the operators have to kind of take the equipment more like a kind of a black box so that they cannot do much of innovation except using them and renewing their licenses to continue to operate those kind of networks. So then another important point is dedicated protocols. So I have not shown you so far about the protocols. I will come back on this in the following classes. Unlike in internet where we talk about TCP IP protocol stack and with some variations depending on whether you want to support voice or data. Here we have tons of protocols between different network functions in 4G and 5G systems. There are lots of protocols and lots of protocol stacks that are defined. Till the point of CUPS, which stands for control and user plane separation. The control plane and the user plane in 4G networks are kind of tied together. There's no clean separation. Later in the 3GPP releases, CUPS feature came into picture that has kind of become one of the starting points towards 5G evolution. Let me show you what are all the things that have happened as we are talking from 4G to 5G. So unlike 4G where we have these functional entities where each box or each entity in the network does certain kind of functionality, in 5G everything is defined in terms of services. So I will show you what I mean by services in the following slides. So everything is a service. Every network function offers one or more services, and what it is kind of offering is kind of exposed using standard APIs so that other network functions can consume those services. We use something called service-based interfaces for this kind of communication between network functions in 5G core especially. And the other thing that has happened in the case of 5G core is adopting the advances that happened in cloud computing, where rather than using these dedicated hardware and getting the network functions implemented on that hardware by the manufacturers of that network functions. Here the operators have the choice of using commercial off-the-shelf general purpose processor, like the way you use your servers in the data center where you can take Xeon processors or Skylake processors, using which we can do different kind of jobs. Here I'm talking about using the same general purpose processors. These are exactly what currently we see in AWS, Google Cloud, and whatnot, where with nice software abstraction layer on top of this general purpose processor, you get a illusion of having infinite amount of compute and storage resources. But actually, if you tear down that kind of abstraction or the illusion, at the bottom, it is nothing but same computers that you see in our campus data center, which we use it for our different research activities, on which these kind of software defined networking and other kind of abstractions are added, so that we can able to take care of the faults that are happening in the networks and the link failures and whatnot. But at the high level, you get a nice solution of as if you have a supercomputer with lots of storage and lots of computing power. So none of these clouds that I'm talking about, they don't really use supercomputers. Yes, there are some supercomputers with lots of storage and lot of computing that are used for high-end scientific calculations and other things. But all the public clouds that you see, they don't really use those things because they're purpose-built and they are damn expensive to build and also maintain and also to replace as the hardware becomes obsolete. So the beauty of the current cloud that you see is on general purpose processors. The same thing has kind of been adopted in the 5G core as well, where we can use these network function virtualizations, virtual machines, and containers to orchestrate different cloud resources to realize different network functions, so that operator can kind of significantly cut down their capital expenditure and also the operational expenditure. And this is another remarkable feature that has happened. It is a kind of the cellular networks which are kind of evolved quite independent from the way internet has evolved, is they also started embracing the protocols that are kind of quite popular in World Wide Web and internet. So again, here what I'm going to talk about in the 5G core, here it is EPC. So I'm talking about network functions that are implemented as virtual network functions, talk with each other using HTTP or HTTPS. So rather than using proprietary communication protocols. So that's the meaning of using the word harmonized protocols. That way one can easily write these kind of applications because we have tons of people out there who understand how to do software development using HTTP kind of protocols. And you already seen the cups in the later evolution of 4G that has become a default when you go to 5G core. So before I talk about what is the 5G core architecture, let me tell you some basic definitions, even though they seems to be a bit abstract. Just bear with me for a couple of minutes to understand what I'm talking here. So what is 5G system? It is nothing but 5G access network along with 5G core network and user equipment. So together, all these are called 5G system. That I guess you might have already known by this time. What is 5G access network? This could be the next generation RAN that 3GPP has defined, or it could be some non-3GPP access network connecting to 5G core network. Example could be operator deployed Wi-Fi network connecting to the same operator deployed core network. That is also possible. Then comes network functions. Here these network functions are the kind of network functions which are either defined by 3GPP or 3GPP might have adapted these from other standardization bodies as well. The only important point should be noted here is each network function that you use in 5G core comes with 3GPP defined interfaces. So using these interfaces, these network functions can talk with each other, where if you look at any network function that is there in 5G core, it can offer one or more services for other network function to consume. As I was mentioning, 3GPP doesn't really talks about how one should implement these network functions. They only care about the functionality and service level quality that we expect from that. As you see, there are three different options that you can think of. One is you can take this network function and implement on a dedicated hardware. That's how up to 4G, 2G to 4G, it has been done. So most of the operators kind of buy these network functions like MME, S gateway, P gateway from manufacturers like Nokia, Samsung, Ericsson, and etc. And they start using in their data centers for offering these 4G services or other kind of cellular services. But in the last 5 years, thanks to the advances that have happened in internet with the cloud computing, SDN and NFV, it is possible for you to take a dedicated hardware. That's where I was talking about using general purpose processor on which you can deploy the 5G core functions as software instances. Even in our own campus, very recently we have got some of the access point for one of our academic blocks. So there we had two choices when you're talking about deploying a wireless LAN controller. So one choice is the option one that you see it here. The companies like Aruba, Arista, and Cisco, they sell standalone network appliances, which are like a purpose-built hardware with software built in, which does one activity in quite efficient manner. Only thing is you have to spend a lot of money, and tomorrow if that box is not supporting some features, you may have to replace that box with a new box. But of late what we started doing is the option 2 and option 3 even in our own campus when it comes to Wi-Fi, and for that matter all our web server and DNS server, DHCP server, all of them are running on our own private cloud, where we have taken this functionality, which is nothing but a piece of software, rather than running the software on bare metal by installing the software directly on the operating system. We take private cloud in our data center where we create virtual machines and containers on which we kind of realize these software functions. So these are the things that has happened when it comes to data centers and when it comes to internet. So what I'm showing here is even in the case of 5G core or in general for the 5G systems, one can go for one of these three options, but increasingly we are going towards option 2 and option 3 because they have huge savings in the cost for operators. And what is network service? It is a functionality that is exposed by a network function to a service-based interface and consumed by other authorized network functions. Again, I'm repeating. A network function is one that offers one or more services. Each network function offers one or more. For example, a service could be authentication service, or roaming service, or billing service. These are kind of different services that network functions offer. So each service that a network function is offering, it exposes to other network functions using some interface. Here I'm talking about a next generation interface called service-based interface. Other network functions which wants to use this service, they have to kind of get authorization done before they really start using the service. That we want to make sure that these services are not misused or used or exploited to launch any kind of cyber attacks on the operator's network. What is SBA? Again, not the SBA that we use, but it is a kind of a representation of how a set of network functions talk with each other by exposing each other's services. So if there are tons of different network functions, each of them offer certain services. Each of them exposes their services using service-based interface. I will talk further about what is SBA and what are the benefits that we get with compared to what has been done as part of 2G to 4G using something called reference point or point-to-point interfaces. Finally, we have something called NF instance. It is an identifiable instance of a given network function. So network function is nothing but a piece of functionality. At the end of the day, you have to take software and deploy it on one of the container or the virtual machine. So it is possible that operator can have more than one instance of a given network function for load balancing purposes or for redundancy purposes. That way, when we are talking about users connecting to the core network, sometimes they have to be figuring out which instance of the core network for a given network function they should connect with. So that can be kind of stored in some repository using which we can able to identify the right network function and start interacting with that where of course each network function has its own IP address. At the end of the day, we need to know what is the IP address of the network function so that you can go start talking with it and get its services for the kind of work that you wanted to get it done from it. So these are all various definitions that I'm going to use in the rest of the presentation. But at the high level, I'm expecting you should know. What I'm saying is we have something called 5G system comprising of access network, core network, and user equipment. Where ignoring the access network for a while for this talk, in the case of 5G core, we have different network functions to realize different functionality of the 5G core, where each network functions offers one or more services. These services are exposed by each network function for its own consumers, which we call it as authorized network functions. For that, they talk with each other using something called a next generation interface called SBI, that is based on service-based architecture. So let's look at the evolution of 5G from 4G EPC. It has evolved in two steps mainly. One is I was mentioning in the previous slides as well, the separation of the control plane and data plane that happened in 4G EPC. Same thing has been adopted even for 5G core. And the second one, that's what I was talking about as part of the service-based interface, is reorganizing the CUPS functions into services. So now we are moving from functions to services, where each one can be treated as something like a web server, which offers certain kind of services which clients can start using it or consuming it. So in summary, this is what has happened in 5G core. It has adopted all recent advances that happened in software industry in the form of service-based architecture. And what happened in the case of cloud computing, the cloud native containers, virtual machines, orchestration. So all this thing that has happened in cloud computing also has been embraced in 5G core. HDN NFV, most of you know about all that. And even the advances that happened in internet in the form of TLS 1.2, 1.3, HTTPS, and JSON. All those things also has been adapted in 5G core so that we can get the best out of what has happened in other domains to make 5G core as agile as possible, because unlike 4G core, which was meant to support only voice, data, and SMS, 5G core is meant to support even the applications that were not even dreamt of when ITU or even 3GP defined the specification. So they want the 5G core should be as agile as possible to develop new applications and new services as the demand for new services evolve as you go into 5G era. So that's the reason why all these principles have been adopted, our technologies have been embraced in 5G core, so that we can get all these advantages. And also the people who have kind of working in all these areas also can become workforce in developing 5G applications and 5G services. That is also another remarkable feature, because up to 4G, only the network engineers and the telecom operators kind of manage the networks. But that should not be the case any longer in the 5G systems, because as you see, the 5G systems going to offer services across many business verticals. For that means the application developers working in various verticals should at least get a high level flavor of what 5G is, so that they can able to use that kind of an API and start developing their applications and take advantage of these innovations. So I have shown this slide, if I'm not wrong. Did I show this illustration earlier? Can somebody confirm me? Did I show this slide earlier?
I'm not sure.
No? But okay.
I'm not sure about this.
Or at least this part?
Yeah, that part maybe, but not the entire slide. I think.
What do you mean by maybe? Okay.
Because
So,
these things I have seen earlier, like MME, HSS, and these things are converted
okay.
to.
So anyway, I will talk quickly about what is CUPS and how CUPS has been adopted again in 5G core. Okay.
Okay.
So let's look at on the left-hand side, the top part. So this is the part. So what you're seeing here is the EPC of the 4G networks, where you see we have different network entities like MME, HSS, PCRF, S gateway, and P gateway, where P gateway and S gateway does the routing of the user traffic. MME is a kind of a control plane entity which takes care of the mobility and other uh, authentication and other kind of services using HSS as the backend, which is a kind of a all the subscriber information. So your key details and your subscription information, all that is kind of stored in HSS database. PCRF is the policy and charging rules function, which kind of pushes the policies. Accordingly, the P gateway can do the throttling of the user traffic. If we are having, like you see, right, sometimes after you consume 1 GB of the data, your data rate will come down from unlimited to 128 kbps. So those kind of things can be pushed from PCRF to the P gateway so that we can do the rate limiting at the P gateway. That is the traditional 4G EPC architecture. So with CUPS, what has been done is separation of the control plane and data plane, where you can clearly see uh, the user plane entity, that is S gateway and P gateway, has been separated into two components respectively, where we have control plane version of S gateway and data plane or user plane version of the S gateway. It's clearly separating the control plane and user plane, as simple as that. That way, when we are talking about pushing the user traffic between base station and the internet, so the S gateway user plane and P gateway user plane only comes into picture. That way, we can have separate evolution for control plane functions and also for user plane functions. Now, what you see on the right hand side is how that CUPS uh, has been embraced in 5G core. And also you can see the mapping between 4G network functions and the 5G network functions. So look at what you see at the bottom. What it is a kind of telling, the user plane of P gateway and S gateway has been combined into a new network function that is called UPF. So these two together has become UPF. So then the easiest part here is the PCRF that became PCF. There is no merging or there is no splitting happened there. And if you look at these HSS with AAA server, so that has become something called AUSF and UDM, where AUSF stands for Authentication Server Function, and UDM stands for User Data Management or Unified Data Management, so where, as I was mentioning, HSS contains all the subscriber information, including the keys for authenticating the users and other things. So similar one that we have in the case of 5G is the UDM, the Unified Data Management, with something called UDR as the backend database repository. Authentication server function does something called authentication. When you are switching on your mobile, before you do anything, the base station, with the help of the backend core network, in this case it is a USF, it verifies that you have right credentials to access the network. So first you have to authenticate yourself with the 4G or 5G network. So that is what being done by AUSF by referring the UDM as the backend repository. The two main functions that you see in 5G core are the AMF, this is called AMF, access and mobility management function, and the second one is the SMF, session management function. And as you see here, the mapping between 4G and 5G, the part of MME, the control plane versions of S gateway and P gateway have been merged into session management function. And the rest of the MME has been brought into access and mobility management function. Okay. And also you see, I have not talked about this earlier, but since I was talking about these service-based interfaces and other thing, you should pay attention to the links that you see even in the 4G architecture and even in the 5G architecture. Look at here, you see dotted line here. So the dotted lines here kind of signifies that these are the control plane interfaces. The solid lines that you see here, S5, S1U, and SDI, these are like a kind of a user or data plane interfaces. That is point one. And another thing that you should note down here is, if you take any two network functions, even for that matter, even if you take the CUPS version here, if you take S gateway and P gateway, they have one user plane interface, which is a point-to-point based interface. What basically meaning of point-to-point is, between every pair of network functions, we have one standard unique interface that is defined. That means if they want to talk with each other, they have to know what is the interface, and accordingly they have to compose the messages and start sending using that particular API that is defined exclusively for that. So because there is a certain standardized and unique interface, even though that is quite good in terms of understanding and communicating between them, when you're talking about the scalability of the network function, there could be some issues. So those are the things kind of addressed as you go toward the 5G that I will talk about as part of the SBI. But in 4G, even to some extent, even in 5G, you can see that we are using something called the reference point, or also called point-to-point interfaces, which are nothing but exclusive or one-to-one interfaces that exist between two network functions to realize whatever the functionality they wanted to realize, or for whatever the communication that they wanted to have between them. So, okay, yeah, I think that is also kind of coming here in this slide. So there are two kind of interactions that are possible between network functions in 5G system. So it is not just 5G core. Here I'm talking about 5G system. That means comprising of both core network and access network. One is the legacy one, which we have used all the way up to 4G, is the point-to-point, also called a reference point representation or interfaces. And the second one, which is new and which what 3GPP has kind of decided to go ahead with, is called service-based representation based on service-based architecture. So this is point-to-point architecture, and this is service-based architecture. And even though I'm talking about this new SBA here, for some of the network functions, still we have the point-to-point interfaces, even in the case of 5G system. That is true especially from user equipment to the AMF, and also from base station to the AMF. So only in the control plane, we are kind of started using in the 5G core, where you have the control plane functions. So we are using SBA more or less. For the rest of the things, which involves even the access network, so we are still using the point-to-point, not P2A, point-to-point architecture. So I'll talk about what is this and why we are doing all that in the following slides. So before we talk about the service-based architecture, let's look at point-to-point architecture. So this is how the 5G system architecture has been defined, which based on point-to-point or reference point architecture. As you see here in the slide, between every pair of nodes that you see, if you take any nodes, if you take RAN and UPF, we have one interface. It is a point-to-point interface named as N3, which exists between them. So when RAN wants to talk with UPF, it has to use this API for their communication. Similarly, if the UPF wants to talk with the data network, it uses N6. And if AUSF wants to talk with UDM, it uses N13 interface. So like that, there exists a point-to-point interface, which is standardized by 3GPP, and it is unique between a pair of network function that you see it here. It is good. This is what I was mentioning earlier as well. It has been used for last 30 odd years, all the way from 2G to 4G networks. So it is trusted and it has been well established in the industry for many, many decades. But the problem with this kind of approach is it creates a lot of dependencies between network functions. Tomorrow, if you wanted to upgrade this with the new features, what you have to do? You also have to upgrade N6 and also tell data network to follow this upgraded interface and all these features. It is good, but as you see, there are lots of network functions that you have here in the 5G core. And when you have these many point-to-point interfaces which are unique between pair of entities, it creates a tangle of connections with lots of dependencies between them. So it makes it very inflexible to introduce new functions or new services. That way, we cannot have agile way of doing the things. That is not possible when you go ahead with this traditional approach of having point-to-point interfaces. So to address this, we have something called the service-based interfaces in 5G core. So what we do as part of the service-based interfaces is we treat each network function as either producer or consumer of the service. Let's look at this cartoon where you see I have two network functions, one is A and other one is B. So what we say is, or we can kind of say each network function as a collection of one or more network services. In this particular case, you see clearly network function A is producing service A1 and network function B is producing service B1. And also if you look at closely, the network function A is consuming service B1 which is offered by NFB. Similarly, NFB, that is network function B, is consuming a service that is A1 which is produced by A1. So that way what I'm saying is each network function can be treated as either producer or consumer or as both. That means for some of the services it is a producer, some of them it is a consumer, and vice versa. That all those are possible. Then there are two ways of talking with each other using these SBI interfaces. One model that has been standardized is request and response model, and other one is the subscribe notify model. So as the names imply, network function A, when it wants to get it is opposite. When the network function B wants to get a service from network function A, it has to make a request to the network function A. In this case for service A. For service A1, it is making a request, and for that, the network function A is replying. Whereas in the case of service B, service B1, network function A is kind of subscribing, and network function B is kind of notifying if at all there is an event, and that kind of satisfies that particular subscription. So does it make sense? Can you able to think of any other place where you might have used this kind of request response messages or subscribe notify messages? Can you think of any other place where you might have seen this kind of architecture for communication between two entities? Can you recall or can you think of? I have two functions or I have two systems who want to use request response model, and other one is they want to use subscribe and notify model. All of you know these kind of things. It is very common in internet. So can somebody tell me where in internet we are using this kind of communication paradigms for getting services from other computer systems?
So in case of notification systems for different applications, we generally like subscribe to that service and we get notified. And
Yes. Yeah, nowadays I think with apps you get lots of notifications, right? Yeah, that is, yeah, you can treat that as, yeah, maybe you can have subscription to Google News, and
Yes.
whenever there's a new news item, yeah, you'll be notified about that. Yeah, that could be one example of subscribe and notify. Also, you might have heard about something called RSS feeds, where when a website has dynamic content, or when you let's say when you're looking for new updates on a given particular website, and a good example is Google News itself. You can also subscribe for RSS feeds, and even when you talk about ACM Digital Library or IEEE Explore, you can have subscription for some magazines and some kind of journals. So whenever there's a new content that is published by those libraries, they can notify you that okay, new content has been added. So that way, this kind of subscribe notify is very common and it is very versatile. We use it at multiple places. So we can also use this kind of subscribe and notify model even in the case of 5G core, where one network function can subscribe for services that are offered by other one, and as soon as any thing of that nature has happened, it can notify the subscribed consumer. Okay. And other model is the request and response, or request or reply. So can somebody tell me where to use this request response paradigm for communication?
Something like DNS, where we send a request to DNS servers and then we get reply.
Yeah, you are right, Harinder. Yeah, one is DNS, but but it is even more popular than, of course, DNS is very popular. Without DNS, you cannot do anything. But there's also something in internet where you use it in the same way, request response. What is that?
Sir, HTTP.
Yeah, it is there in the slide also, right? Yes. In the HTTP, we send get messages requesting objects from web server, right? So that way here, I can also say this is a web server B, this is web server A. As you see here, each web server is providing certain services or producing certain objects, which other web server is interested in. But when one web server is interested in the services of other web server, that becomes simply a client, not a server. That way we are kind of seeing a dual role of both client and server in the case of network functions here, depending on whether they are producer of the services or consumer of the services. So this is what I'm talking about as service-based architecture using service-based interfaces. And here, all these messages, subscribe, notify, request response, all of them go over HTTP. That's it. So we are talking using the most popular protocol that you use on www, that is HTTP or HTTPS, for communication between network functions in 5G core, either using request response paradigm or subscribe notify paradigm. So rather than using something like a point-to-point interfaces, which are kind of unique and may not scale as each network function is evolving for whatever the case may be. Let's look at the most popular 5G system architecture, which is based on service-based architecture. Okay, I didn't talk about I didn't talk about what are all these entities, but I think now you can see before I show further. So you can see, maybe I'll use this laser pointer. So this is user equipment. This is access network or radio access network. This is user plane function. This is the data network. It could be like internet or corporate network. So as you see here, these are all the interfaces that you see here. Here it is not shown, but it is called, okay, I cannot write now. It is called UU interface between UV and RAN. Okay, that is not shown here. So you have N3, N6, N4, N2, and N1. And you should not be confused here when you see user equipment is talking with AMF over N1 interface. Again, all these interfaces are logical interfaces. There could be multiple network components in between before they reach to other end of the interface. For example, when user equipment wants to authenticate, when you switch on your mobile, it has to get authenticated with AUSF. But for it to get authenticated by AUSF, first user equipment has to talk with AMF. But again, it cannot talk with AMF directly because it is a radio unit or it is a mobile radio, and only the base station has a radio in component in that. AMF is mostly like a kind of a wide component. So the messages that you see to are of N1, they go via RAN and reach AMF. Once the messages reach AMF via RAN, AMF internally talk with ASF, and because as I was mentioning in 5G core, we are using this request response model or subscribe notify model. In this case, for authentication of the user, we use something called request and response, where after you send your request for authentication to the AMF, AMF is kind of making a request over this service-based interface architecture that you see it here to ASF. And ASF internally talk with UDM, where the credentials of the users are stored, and does authentication. And the outcome of the authentication is conveyed back to the AMF. It will again come back all the way through RAN to the user equipment. So that's how they use these different interfaces, which are again logical interfaces. Everything here is a logical. That's what I'm saying it here. Now let's come back and look at this dotted line. So this is what I meant by 5G core, which is based on which is based on service-based architecture. So unlike the reference point architecture that you see it here, this is the reference point architecture that you are seeing it here. So unlike this, where you have point-to-point interfaces between two network functions, look at how the architecture is dramatically different here. So we have something called like NEF, NRF, and NPCF. The way you're using prefix N, I think same thing has been adapted here. So these are the service-based interfaces that have been defined. So each network function, whatever the services that it is offering, it exposes using this particular interface. In the example of AUSF, it offers its services like authentication to AMF or to whoever it is to whatever the other network function that are interested with its services using an AUSF interface. Then AMF makes a request by following that particular notation and makes a request, and this guy responds back. So like that, you see there's a standard interface for each network function in the 5G core, which are based on service-based interfaces. Together we call this as service-based architecture. All the communication between all these entities in the 5G core happens using HTTP 2.0. So where we are talking about using HTTPS with the TCP as the underlying transport layer protocol, but in future we can also replace TCP with QUIC as well. You feel that TCP is becoming a bottleneck due to various issues like head of the line blocking or whatever it is. So the way, so this what you are seeing here is the collection of 5G network functions, which are kind of defining service-based interfaces for communication between themselves using HTTP 2.0 based messages. Okay. Let me tell you now what all these different network functions that are there inside this 5G core or 5G control plane function. These are all 5G control plane functions, and UPF is the only one we have in the 5G core which is not control plane function. It is the user plane function. So in this slide, I'm showing only one instance of each of them, but there could be multiple instances of various things like AMF, SMF, and EPF. And user equipment has to know which one it should talk with, all that. That we'll discuss later. Let's look at what are all these entities in the following slides in a bit more detail. But at the high level, AMF stands for Access and Mobility Management Function. And SMF stands for Session Management Function. And we have UDM, that is Unified Data Management, which I also mentioned earlier. PCF is equivalent of PCRF in 4G. Then we have two interesting network functions that are called network repository function, network exposure function. Network repository function is nothing kind of a broker which kind of knows about what are all different network function instances that are out there. And whenever one network function wants to make use of the service of other network function, they have to first talk with the broker to figure it out where all the instances are currently available. That information is stored in the broker. So you can treat this NRF more like your DNS server. The way DNS server does the mapping between domain names and IP address, NRF does the mapping between a given network function and an IP address, which kind of tells the server or the virtual machine where that particular network function has been deployed and instantiated. That is the network repository function. So it is there somewhere here. Yeah, network repository function. So finally, we have something called network exposure function. As the name says, this function kind of exposes the services or the events that are happening in the 5G system to third-party network functions. So it is a kind of very innovative or kind of transformative decision that has taken by 3GPP as part of the 5G, where up to 4G, the cellular systems are meant to provide voice, data, and SMS services, and operators are expected to provide these services irrespective of what kind of application layer content that is going on. So whether it is a Netflix or Amazon Prime or Savan Music, or whether it is a browsing of your e-commerce or like a Skype kind of voice call, the operators are not supposed to distinguish between all these services. They are supposed to only provide a pipe which doesn't distinguish between all these different services. That's where you might have heard about net neutrality and all, where service providers or the network operators should not differentiate or prioritize certain application traffic over other traffic. So that is one of the key principles of internet architecture, and that is the reason why you see that internet is not kind of hijacked by certain few companies. So there's a lot of debate you might have heard about on the net neutralities in general. But net neutralities comes only in the context of internet. But here it is a kind of operator deployed thing, because in internet, it is a collection of networks that are deployed by different campuses and different organizations, which wants to interconnect with each other and able to send each other's messages for whatever the application that they have on top of that. But 5G, or for that matter, any cellular network that we have, is not an internet. It is a kind of a network that is provided by service providers for offering certain kind of services like voice, data, and SMS. Up to 4G, these are the only services that we have out there. But from 5G onwards, where the operators are really looking forward for embracing or kind of providing their services even to other business verticals. There, you can expect like corporates and even governments and even other organizations want to get more details about what is happening in the network. So that information can be obtained through network exposure function. So for example, if you want to know where the users are currently located, that information is already there with AMF and also at UDM level. But this information is only known to the operators. But if the operator wanted to provide some kind of a, like let's say a company like Ola or Uber wanted to tie up with a particular service provider and wanted to provide some kind of service to their customers or their cab drivers, they can have some other application function or some other kind of web server which is somewhere else on internet, which is kind of talking with this particular 5G core through this network exposure function. What this exposure function kind of does is, for example, if the Uber system kind of subscribes to the services like the location service of the Uber users or the Uber drivers, whenever there is a change in the location of the user, that information is anyway available in the core network. That can be immediately notified to the Uber server or Uber system through network exposure function. So that way, the model that is kind of followed that is the subscriber and notify. So the external entities are the third-party network functions subscribe to the events of the 5G system through the network exposure function. So whenever an event takes place or whenever there is an update, that information is kind of relayed through the network exposure function to the third-party services. So that way, it kind of opens up lots of different businesses and lots of different applications that can be expected in future because of the presence of network exposure function. And one last function that you see it here, which also can be based on service-based interfaces, but you may not really say it is part of the service-based architecture, is the application function. Like let's say if the operators like Airtel or Jio wants to offer voice over 5G, then they can deploy their IMS system. Earlier I was talking about IP multimedia subsystem that is used to provide voice and other kind of services by the operators. So application function is one such thing that can be used by the operators to provide their applications. It could be like voice or like video conferencing or any kind of services that operator themselves wants to provide. They can do that. Or it could be that example that I was mentioning in the one of the earlier classes, where if let's say Airtel ties up with Facebook or with Google, they can deploy the services of the Facebook or Google, where the Facebook or Google can kind of trust, the Jio or Airtel can trust the services of the Facebook or Google and provide all this information that is collected in 5G core to this application function, so that this application function can leverage this additional knowledge in better serving the users. So that way we have use cases related to exposing the network events to the third parties, or even the third parties can bring, or even operators themselves can deploy new services where the application function can start interacting with the 5G core to be able to understand the state of the network and appropriately do the provisioning and take advantage of the additional knowledge here. And this service-based architecture that I'm talking about here is in general falls in the context of client server, where we can use either request response or subscribe notify. Unlike up to 4G, where we are talking about using a point-to-point architecture, in the case of 5G, each network function is autonomous, self-contained, and it can scale independently and it can grow independently of other network functions. Where each network function is kind of registers with NRF. That's what I was mentioning. As soon as you create one new instance of AMF, that has to go and tell to the NRF that, okay, I am so and so, my IP address is so and so, and these are the services that I can offer. So tomorrow, if some other network function wants to talk with the AMF instance, it will query NRF and comes to know that what all instance of the AMF available, and it either can give one of them, it wants to do load balancing, or it can give all of them and let this guy decide which one to use it, depending on the application that it has in mind. So that's what out there. And this service-based architecture also comes with lots of interesting features like stateless. That means we can make 5G network functions or the 5G core network functions as stateless. The beauty of the statelessness is you can do the migration and you can do the scaling quite easily. When the network state is not saved at in the place where it is currently running, and if you move the state of the thing at somewhere else, you can easily migrate the service, because migration is in general involves copying the memory image. If the function itself is stateless, you don't have to do anything of that kind. Only UDM is meant to be having a state-based approach, because it is after all a database containing all the credentials and details of the users. Except that all other network functions are stateless. They can be easily migrated, and they don't maintain state information, and also they can cache the information. The caching advantage is quick response time when you are getting same kind of request again and again. So same slide with the one exception here that you see is unlike the previous slide, I'm showing you two more entities here. are two more points I want you to highlight. One of them is, so this is one, something called network slice selection function. So I was mentioning about 5G network is supposed to cater to different businesses by providing services like enhanced mobile broadband, massive MTC, and also ultra reliable low latency communication. Even under each of them, there could be different virtual networks that can be deployed to cater to different business verticals. So that is, network slice selection function is a kind of network function that kind of helps operators to deploy these virtual or logical networks on top of the physical networks by stitching together these logical components that you see in the 5G system. So that is the role of the network slice selection function, where your user equipment, let's say if it is part of IoT slice and if it is part of EMBB slice, and first it has to talk with the AMF, and AMF will talk with NSSF and comes to know that what are the slices that are currently out there and which slide that user should be talking with that. Then of the appropriate AMF and SMF, the user equipment will start talking with. So that is what the role of the network slice selection function. And also you can see here both the dotted line and solid lines. I was mentioning earlier the solid lines were meant here in general for data plane or user plane communication, and dotted lines that you see it here, they are meant for control plane messages. So these are all our logical interfaces. And you can see here, there is also some point-to-point interface, that is N9, which is basically meant for two UPS to communicate with each other. That is the meaning of self-loop that you see it here. Okay, next, I think 5 to 8 slides, I'll be talking about the functionality of each of these 5G core functions in bit more detail. So this is one of the important point, that is so you see it here. This is the RAN, that is the base station. So the control plane interface from the RAN is terminated at EMF. Similarly, when the UU is talking with the 5G core, we have N1 interface that is also terminating at EMF. As you see here, EMF is a kind of playing as a kind of an anchor, and internally it is doing lots of other activities by talking with other 5G core functions. From the RAN point of view and from the user equipment point of view, their endpoint is the AMF through N1 and N2 interfaces respectively. And again, it also talks about the termination of N1 interface that is coming from UV. And we have something called NAS, which stands for non-access stratum. Non-access stratum, and other one is called AS, which stands for access stratum. So in simple terms, access stratum is nothing but something that you do it over RAN wirelessly. And a non-access stratum is the one that is not specific to RAN. So that is the meaning of that. So when you're talking about ciphering and integrity protection from the user equipment to the core network, which doesn't involve the base station, those messages are directly transferred from the user equipment to the core network over something called a NAS system, or we call it as NAS messages. Again, if I come back to the discussion that we had in the beginning of today's class, where I was talking about the dual connectivity case, where the user equipment is talking with E node B and also with G node B. Let's assume that the anchor is, or the master node is the G node B, let's say. So because it is the G node B, both the control user plane and control plane goes here, and the user plane goes here. And again, the user plane and control plane goes here. Then we have the in 5G core, then we'll have again we have the user plane and the control plane. So this is the kind of architecture that I was talking about there, where you see these messages, the control plane messages that are coming. We have two kinds of control plane messages. The control plane messages that are exchanged between the user and the base station, and you have the control plane messages that are exchanged from the user and the 5G core. So the one that are exchanged between the user and the 5G core, the example that I was talking about is the authentication of the user. So these are called NAS messages, non-access strata messages. But the control plane messages that terminate at the base station when the user is communicating, they are called access strata. So these are the kind of RRC, that is radio resource control messages. And these are kind of authentication and other kind of messages, which are kind of goes all the way up to the 5G core, where the eNodeB bit does only pass through. It doesn't do any kind of processing of the messages. So that's what the meaning of this NAS and AS that we use when you're talking about 5G communication. So it does registration management, connection management, mobility management, and provide transport for session management messages between the UV and SMF. Okay, access authentication, authorization, location services for regulatory services. If the regulatory bodies want to figure it out where the current some user is, that kind of can be provided with the help of the AMF, because it tracks the current location of the user at the level of either base station or at the level of something called location area code, which is nothing but a collection of multiple base stations. Security anchor functionality, and talking with even with the non-3GPP interworking functions, all of that will be done by AMF. That way, AMF is a kind of very, very powerful entity that we have in the 5G core in the control plane to manage 5G system. And when you look at the session management function, again, as the name says, it establishes bearers. So basically setting up the sessions, modifying the sessions where you wanted to provide more QoS guarantees, or you wanted to tone down the quality of the connection. All that can be done as part of the establishing, modifying, releasing. And it also does this IP address allocation, where we have a DHCP version 4 or version 6 server running at SMF, which provides dynamic IP addresses to the users. And it also configures the traffic steering at UPF to route traffic to proper destination. So that way it tells the UPF where to steer the traffic. So that way SMF is quite powerful in terms of steering the traffic. And termination of the interface towards the policy. It also talks with the PCF, and accordingly it will pushes the policies. And it also does charging data collection, and it also does downlink data notification. When you are getting WhatsApp and Facebook kind of notifications, or any notifications or messages from internet, first it is the one SMS that gets the messages, and accordingly will decide, does something called paging, where as part of the paging, it kind of informs the user that you are getting some incoming messages. Then your phone changes the state of the radio and start receiving the messages. After that only your after that only your smartphone starts sending a beep or a vibration so that you can start reading the message. Before you do all that, these are the things that happens in the background for you to get these notification messages. And UPF is the only one that we have in the 5G core in the user plane, which does the packet routing and forwarding. And it also does buffering of the packets, especially when the UU is currently not in the active state. Okay. And it also can do DPI, a deep packet inspection if you want to do. Either you can have a firewall that is attached with UPF, with the DPI and network intrusion or prevention system. All that can be done here. And it also can provide the QoS guarantees. So earlier I was talking about establishing a bearer from the user to the P gateway in the context of 4G. Similarly, from UV to the UPF, we can have a bearer. Bearer is nothing but collection of one or more IP flows with the QoS guarantees. So I'll come back what is the QoS model that we have in 4G and 5G later, but we have much better QoS in 5G compared to 4G, where even the QoS that you have in the 4G is powerful than what you get with internet. Because internet, what you get is only the best effort thing, but it is again a different interesting case study how internet provides you all these the audio and video conferencing services even on top of a best effort network. So much innovation has happened to get some decent real-time services running on best effort network in internet. But by design, cellular networks provide you some QoS guarantees. The granularity at which you can provide QoS in 5G is much higher than what you can get with 4G. With that, we can even talk about providing support for mission critical services in 5G. PCF, as the name says, it does the functions of enforcing the policies, okay, and where it can keep track of all the things that are happening in the network, and also it can do something called event reporting to the application function, where this application function can be third party one, or it could be the one that is deployed by the operator, or it could be a local thing. So all that can be done by, so PLMN is nothing but a mobile network, public land mobile network. So public land mobile network, okay. So example is like 4G of Airtel. We can call it as one PLMN, and similarly we can think of even other cases. So UDM, it is a unified data management function that we have in 5G, which does the generation of AKA credentials. So each user is given some keys, like when you buy a new SIM, we have the credentials or the keys that are embedded inside the SIM card. Same thing is also stored in the UDM, so that the keys are there at both the parties. Using these permanent keys, we generate some session keys, and using which we encrypt and decrypt the data. So that way UDM is the one that does all this kind of generation of the AKA, which stands for authentication and key agreement, which are basically for creating session keys for data transfer. It also does the user identification. Let's say tomorrow, if you lose your mobile phone, and if you complain to your operator that I lost my mobile phone, they have something called EIR, Equipment Identity Register, so which is connected to the UDM, where they can mark your lost mobile phone as blacklisted. That way, whenever your phone is switched on again, they can able to check with the UIR database to find out whether it is blacklisted or not. If it is blacklisted, yes, yeah, they can stop providing any kind of services on that particular mobile phone. So that's what user identification handling means. And access authorization is another important feature, because with 5G we are expected to have many kinds of services which are based on the subscription base. Like already have seen with 4G also, we have different packages and with the different top-up amounts, which are all nothing but different subscription plans. So all that can be maintained at UDM, and accordingly the PCF and UPF can be configured or kind of notified to be able to enforce this kind of subscription policies and do the billing and charging accordingly. So this is how we have something called a backend database registry, that is a unified data repository, which stores all sorts of info. It stores the subscriber data, it stores the policy related information. It also stores structured data for exposing to third party application functions or the network functions. So if it is a subscription data, the UDM will talk with UDR to get the subscription data. And if it is a policy data, the PCF talks with the UDR to get that data. So then the network exposure function will talk with UDR to get the exposure data and gives that information to the third party application functions or network function. It could be any of them. So then we have the two main things that I was mentioning, very critical and interesting in 5G core. One is NRF and other one is NEF. Let me first talk about what is NRF. So it is a kind of internal broker which exposes the services offered by various producers so that consumers can start consuming them. So we can treat this more like a glorified DNS server. It's not exactly a DNS server, but it contains lots of information similar to the way we have the DNS server. For example, for each network function, like you can say that whenever you create a new instance of a given network function, we have something called a network function profile, which is nothing but the identifier of the network function and all the slice related identifier. That means in which of the slices the network function can be currently part of that. That is the meaning of slice related identifier. The PMLN ID that I was mentioning about it is like operator identifier. And what is the capacity of the network function? So that way, by knowing the capacity of the network function, when the NRF is bombarded with lots of requests for a certain service, the NRF itself can do a load balancing. So it is very similar to the way we have these DNS servers can help you to do the load balancing, and we can also see like Google search and all, they use one front-end server to accept all the Google search requests and pushes these requests to one of the backend servers for responding. So something of that we can do by knowing the capacity of each network function at the NRF level. So yeah, so the reason why I'm using the word a glorified DNS server is it also contains the IP address of the network function. At the end of the day, for a given network function to start getting the services or using the service of other network function, we need to know the IP address. That information is also stored inside this glorified DNS server. And authorization related information is also stored so that only authorized network functions are allowed to start reaching out and getting the services. Only for authorized network functions, NRF will respond and give the whatever the data that is required so that they can start talking with them. And it also provides something called a discovery service. Maybe I will explain that with this small example that you see here. So look at the example. So this is the NRF, which is the broker. It is the internal broker. The meaning of internal broker is this broker is available for all the network functions of the 5G core. So the example that I'm showing is AMF wants to get I think the example is very generic. The AMF is here the producer and the PCF here is the consumer. Okay, so I have one producer and one consumer. So whenever you create a new instance of this AMF, over this particular step, you register this network function profile with NRF repository. That is the step one, that is the registration of the service. And any consumer, an example here is the PCF. Whenever a consumer wants to get services of an AMF, it has to first get to know what is the IP address of the AMF and what are all different choices of the AMFs that are available. That information AMF doesn't know directly. Very similar to the way when you wanted to go to google.com. So you only know the domain name, you don't know what is the IP address. For that, you contact DNS server. So very similar concept here, where NRF is acting like a kind of a DNS server, where the consumer in step 2 is doing the NF service discovery. It is more like a DNS request. And it also has to provide its authorization detail so that the NRF receives the service request or service discovery request and check whether the consumer has credentials to consume the services that are offered by the producer. If If that is true, then it will reply back stating that, okay, I have these many AMFs and these are their details and these are their IP addresses. Or if it is only one of them, it gives only that particular details. Finally, now we have step 3, where now I know what is the IP address of AMF. Now PCF can directly start talking with that using HTTP messages, HTTP and JSON messages. Of course, we'll be using HTTPS. Okay, that's what I meant by secure communication with respect to authorization tokens. So we use something called OAuth in internet for unified authorization services with service authentication tokens. Same thing can be even applied here too. So in summary, let's see an example of user authentication at a high level by using various network functions in the 5G core. So what you see at the leftmost is we have a request that is coming from the user for registration with the network. That is what you are seeing it here. From the user, the request will come via the base station to AMF. What AMF is doing, let's see. First, AMF is requesting AUSF using the service. As you see here, I'm talking about the request and response. So that way it is a kind of consumer and this is the producer. And look at the interface name. It is using NAUSF. That means AUSF is a kind of providing the request response service. Here AUSF is the producer and AMF is the consumer. For that it is giving lots of details. So don't worry about the acronym, but at the high level, assume that a request is coming for authentication from AMF to AUSF. So this is the request. Now AUSF has to respond by sending a reply, which could be either success or failure depending on the credentials that we have. But interestingly, see what is happening here. AMF is not responding immediately because AMF alone doesn't have all the information for it to process the request and respond. It in turn is generating another request by playing the role of the consumer, where it is reaching out to UDM on a certain interface that is defined between them. Again, it is an SBI where it's a GET request. NUDM, U authentication GET request. Again, the same credentials like the details of the UE and other things are kind of passed on. But again, as I was mentioning, the UDM is the kind of a function which doesn't have any database. All these guys are stateless. At the end of the day, we have all the database inside here. So we have to query. It's more like a kind of your SQL query that you can do it here, where you are kind of providing all the information and querying this database and get back the response. After that, you check whether everything is okay. Now you got the response, authentication type and the sequence number and the key. So as I was mentioning, we have the key, the AK information that is stored in UDR, and also we have these permanent keys in the SIM card. So some of those details are kind of passed now to the UDM. Now it is generating authentication vector. It is computing some random number authentication and some other key, that is KUSF. It is a kind of session related key for authentication purposes. It is generating at UDM after getting the response. Then it is composing a response message and now responding. Now you see, now it is the producer, right? Now it is, as a consumer, it has now got the response. As the producer, it has created this and has responded. Finally, it is computing the response, X response. Basically, it is a kind of checking whether the identity credentials are matching or not. So we'll come back and see, if at all we have enough time, how authentication really happens between the base station and the core, between the user and the core network. But here I wanted to pay attention to how we are kind of using these the concept of service-based architecture, where different network functions are playing the role of either producer or consumer to be able to generate the request and reaching out to other network functions for the services offered by them and getting the response. Where you are seeing clearly in this case, we are using only the request response paradigm, not the subscribe notify paradigm, at least in the context of the UV authentication. Finally, the authentication response is given to AMF, which in turn responds to the user via the base station. So we have equivalent of NRF when you're talking about the third-party application functions or even the network functions. So that is called a network exposure function. Okay. Otherwise, the functionality is the same. And application function, again, I was also showing in the context of the architecture, it could be either trusted or non-trusted. If it is trusted, you can directly give access with that NRF. If it is untrusted, you give the access through network exposure function. Okay. So all that can be done here. And the last one that I have for today is about network slice function. So we'll talk about this in more detail when we discuss about network slicing, how network slice selection function kind of helps in identifying the right network slice or a virtual network for a given services of users. But at a high level, yeah, it is the responsibility of the network slice selection function to identify the target or the right AMF. By default, what happens is each user equipment will talk with something called a default or anchor AMF. So this anchor AMF in turn talk with network slice selection functions to identify the target AMF. So this target AMF is the one that is specific to a slice. For example, you can say IoT slice or V2X slice. That's what happens. Yeah, that's all. Okay, we are exactly on time. So we have some references here, and also the first, I think the second one that you see it here is a nice YouTube webinar on the service-based architecture. So just go and look at it and try to appreciate how the 5G SBA architecture is kind of dramatically different from point-to-point or reference point architecture, and what benefits that is going to give compared to what you have with the 4G. Okay, so I'm done here, and if you are having any class, please go ahead. Otherwise, I can answer a couple of queries if anybody is having.
Sir, when we say there are various interfaces between the user equipment, the RAN, the IMF, for example, user equipment and RAN have an interface N1. Yeah. So when we say interface, is it what is it referring to? Is it some particular protocol that runs among them? I'm not able to get the.
Okay. I think Ranjita will talk about this further in the following lectures, but at the high level for this particular SBA, what you have to kind of assume is, so take this example. So maybe I'll explain this with, take N1 and N.
Okay.
So what I was mentioning is this one is based on HTTP. Okay. And this one, N1, N2, and N3, these are all proprietary. That means that the N1, N2, and N3 could be entirely three different ways of, again, whether it is here also we have protocol stack.
Yes.
But here also we have protocol stacks.
But is it proprietary to 5G?
No. What I'm saying is it is proprietary to say when it is a N1 is something that only UV and AMF can understand with each other. That's it. That means user equipment cannot use N1 interface to talk with AMF.
Sir, yeah, so it is some kind of a way in which the packets have to be organized and sent, right?
It is some kind of, okay,
Yeah, like I mean, when a UE is trying to register, some information has have to go to AMF and then come back, right? So
yes, yes,
that information must go in a certain format so that AMF will be able to understand it, right?
yes, yes. What
So
I'm saying is, we can assume that, say in internet, what we do, when you have two, like web client, web server, so we say that they follow TCP/IP stack,
yes, sir.
and we use get messages and post messages, right?
Yes, sir. Yeah.
So yeah, here I'm talking about using TCP/IP stack and using this as the messages to send all kind of messages, right?
Yeah.
So what I'm saying is, as part of the SBA, we brought in the same architecture.
Okay. Yeah. That is for these
For all the control plane functions.
control plane
Right.
functions. Yeah.
That part is clear to you, right?
Yes, that is clear.
Okay. So now when I come back to here, uh, here between these two, the N1 is something that is specific between user and AMF, and we have something called, let's say I was mentioning it, UE interface. Maybe what I do is we'll which one I should do? Let's assume that this is my user equipment and this is my GNodeB. So I will show with an example of this U interface. Okay, again, this is also a point-to-point interface. So this I will come up in the following class, but anyway, since you asked, I will show you at the high level. So here we use something called, here I'm actually drawing the protocol stack.
Okay. Okay.
So, oh, not this one. Yeah, PDCP. So I will talk about in the following class. Don't worry, what all these do. So when it comes to the base station, it has actually two stacks. On the left-hand side is equivalent to what you see it here,
Okay.
because both of them are wireless. This part is wireless.
Yes.
Again, we have RLC. So here we have, interestingly, more complicated. It is based on GTP. Basically, it is related to GTP tunneling. I will talk about why we need tunneling and other thing later. So then it uses UDP, then it uses IP, then it uses L2, and it uses L2. So like that, unlike the 5G core network functions, where I'm talking about using a TCP/IP stack with HTTP, for all the point-to-point or the reference point interfaces that I'm talking about, there we have this kind of dedicated protocol stack with specific messages that are defined, which only these two guys can understand each other.
Yes, sir. Yes, sir. I was looking for this only. I mean, is there any specific protocol stack? And this is defined by 3GPP,
Yes,
right?
yes,
Sir?
it is defined by 3GPP. I will show you in the following class how many protocol stacks are there. Okay.
Okay. Okay, sir.
We have stacks of protocol stacks. Okay.
Okay, sir. Thank
So
you.
yeah, you'll be understanding that. Again, since I skipped the discussion on 4G and I meant to cover the RAN part, I think the discussion on the point-to-point architecture is abstract for you. But don't worry, that is what coming up in the following class. So, but at the high level for SBA, it is what you already know in internet, which is based on TCP/IP using HTTP and JSON as the application layer protocol and for exchanging the data objects.
Sir, one more query, sir. When we say control plane and user plane, for example, when I'm dialing a particular number, till I start hearing the ringtone, that comes as control plane messages.
You are right. Yeah. Till okay, you are making call. That's what you mean.
Yeah. When I'm making a call,
You are right.
after some time,
All the
we'll
time
get the
lag that you
ringtone.
see till you start hearing the ringtone. Yeah, you can assume that that is the time taken by the control plane to establish the call. Yes.
Okay. Further on, whatever goes is the
No,
user
not truly,
data.
not truly, not truly. Further on, majority of them will be in the user plane, but occasionally you also see cellular networks being wide area network, they also should support user mobility, right? That way,
Okay. Yeah. Understood.
and also when you are making call, also you can see that you are able to get incoming calls.
Yes. Yeah.
And also when you are making call, you can also get SMSs. During your call, you can get OTP messages and SMSs. Did you realize all that?
Yes, sir. Yes, got
So
it.
what does
So
it mean?
it's a mix of both. Yeah, it's
Exactly.
a
It is a
mix
mix of
of.
both control plane and user plane after the call is established. But to start with, you are right that we establish a call. I think you will be, I think I have opened this. I don't want to scare you, but these are the really the messages that exchange when you switch on your mobile phone each time. Each time you switch on your mobile, whether it's a 2G or 3G or 4G. But again, this is in the context of the 5G. Look at how many messages that exchange even before you hit any number. So these are all the messages. 34 messages that you see it here. It is only to register your equipment. After that, when you start dialing the number, then there will be even tens of messages, control plane messages that get exchanged before you start hearing the ringtone.
Okay.
Yeah, so that way there are so many details. And since you asked here, you can see even here, AMF is talking with UDM, where you see the message number 15, 16 and all, where we are talking about using HTTP messages like a request response request, like it's more like a get message and reply message kind of thing, all those things. In fact, it is, oh, sorry, I think the message number 15 is a put message because you are also specifying some additional details. Yeah, it is not just the get, but I think if you look at the message number 3 is the get actually, right? The message number 17 is the get request. Get.
Yes.
Can you see it?
Yeah.
So
Yes, sir.
this is
Request
what
data.
we use it here. Let me see whether we can have any demo of this kind of thing. But we used to have this kind of demo earlier in the case of 4G. So we have to see whether we can give a demo of this. But it is available in open source. We can do multiple things. So this is what I was talking about, equipment identity register, in the where when you switch on your mobile phone, it checks whether your mobile phone is blacklisted or not, especially when you lost when all that. That happens each time you switch on.
Okay, sir.
Okay, any other queries from anyone else? Okay, I think
Thank you, sir.
Okay, Ranjita, and
Yeah,
okay,
thank you.
few of you left. Okay, carry on
Yeah.
then, and if there is anything, let me know again. Okay, bye.
Yes, sir. Thank you.